Hello, welcome to software testing methodologies. Today we are going to discuss about Unit 2. So Unit 2 has two parts. One is transaction flow testing. So in the transaction flow testing, transaction flows, transaction flow testing techniques, and second part is data flow testing, basics of data flow testing, strategies in data flow testing, and applications of data flow testing. So this unit consists of two parts. One is transaction flow testing and data flow testing. In the transaction flow testing, techniques will be there, and what is meant by transaction flows is nothing but basics of transaction flows. In the data flow testing, there is a basics of data flow testing, strategies, and applications. So now we'll go for first part, transaction flow testing. In the first part, first topic is nothing but a transaction flows. So first, what is meant by transaction flows? So generally before that, what is meant by transaction? So this is a familiar word which defines a transaction. So you all well known about the transaction. So by listening this word transaction, the example will be get in our mind is nothing but ATM transaction. So that's it. That's the best example for this transaction flows and transaction flow testings. So this is the statement, nothing but definition which defines a transaction. A transaction is defined as a set of statements or a unit of work handled by a system user. Every information or every number of set of statements or every information need to be transmitted from sender to the receiver or client to the server. It is known as a transaction or a unit of work handled by a system user. Any work handled by a system user is known as a transaction. So bank transaction is the best example for our transaction flows. So these are all some of the statements to define the transaction flows, and it is a collection of operations that are required for handling a particular transaction. The execution of a transaction begins at the entry point and ends at the exit point. Every transaction has an entry point and exit point, thereby producing some results, whether those results are good or bad or positive or negative. So number of collection of operations can be done to handle the particular transaction. For example, we are going to ATM for withdrawing some money. There are number of operations involved for that transaction, withdraw transaction. Those operations are inserting a card, entering the PIN number, entering some amount, or all these are some of the operations. That is nothing but collection of operations which performs the transaction. So at the end conclusion, transaction processing is no longer after completion of the transaction, there is no longer of a transaction in the system. So that is one of the advantage in the transaction flows, and all the results are finally stored in the form of records. Every transaction should maintain the record. So that's why if the user wants to access the data, the user can access the data from the records. So this is about the transaction flows. Next, these are all some of the 12 transaction flow steps which performs a single transaction from starting to ending or entry point to the exit point. So first one is accept input, is the tentative birth of a transaction, validate input, whether checking it is a validate or not, and transmitting the acknowledgement to the requester. So input processing will be done, searching the file, request directions from user, accepting input, validating input, process request, update file, transmit output, and record transaction in log and clean up death. And clean up, nothing but death transaction. So this is the birth transaction, this is the death transaction. Up to here, see this, up to here, this is the user transaction, and from this in accepting the input from the machine, validate input from the machine, and machine will be processed the request, machine will update file after completing the operation, and machine will transmit output to the user who performs the input, who raises the transaction, and that all the transaction details will be stored as a record. So this is the 12 processing steps. Next, coming to the transaction flow, how the transaction flow occurs. So mainly the transaction flow is used to test the structural and behavioral of a system. It is similar to the control flow graph. Generally, a transaction flow is processed in forms. Each form consists of several pages with records. Whatever the information defines in that based on recording about the transaction can be defined in the several pages with records and fields. A system is taken as a terminal controller to process these forms. So every terminal controller here, mainly the system performs the terminal controller to access the input from the CPU or processing the input from the CPU, all whatever it may be, all defines for the terminal controller. Only those forms who are located in a central computer are requested for processing. The terminal controller transmit each page of output to the central computer. So terminal controller also maintains the transmits the code to check the input. So this is the way of transaction flow occurs. And now coming to this same transaction flow in the transaction flow graph, how it is defined. So this is the begin transaction, nothing but here we are defining the decision statement D1, and that decision will be processed, nothing but request from CPU, and that request will be accessed as a process to P1, P2, P3 is the processes, and a request from CPU accept form processing that from which is accepted and which is requested from CPU. So that is handled by this node. It is nothing but a node, which A is a node which transmits that page to the terminal. So see here, this A is a node which so here from here the transaction will be started. Main transaction work will be started. So transmit page to the terminal. So that terminal page will be accepted by the B node. B node performs the decision checking as a more fields. If there is a more fields, then if the more fields are yes, then accept the input. Again go to the another field checking. Again there is a field to be checked. Yes, again accepting the input. The another some other fields will be checked. If still there is a yes, again the checking will be. So this is the checking processes. If the number of fields to be checked. If there is no fields, then transmit output to the CPU. Completion of fields, then the output will be transmitted to the CPU, and that CPU accept that information, confirming messages. That confirm message will be valid. If the valid message performs no, then again transmission will be done to the node B. So node B will be transmitted, again this B will be handled, again this all processes will be done. So if the valid CPU confirmation is valid, then if yes, it performs the more pages again. If there is more pages, again go to terminal node A. Again from this here the entire process will be done. So again, if there is no pages, then user reviews will be performed. If there is any user review, set that review and so on. Whatever the reviews will be defined. And if there is no review from the user, then exit the transaction. So this is about total completion of transaction flows. So here we are taking two nodes, one is A and B. So two nodes will be accepts all the transaction processing steps, including the decisions, including the process steps, including the terminal controller, and including the central computer, and entry point and exit point, all the processes and decisions. So this is about transaction flow graph. Next, all this graph is explained in the points. When transaction is to be initiated, P1 request from CPU, process 1 request from CPU. Then the central computer accepts the form in the process P2, and P3 processes those forms which is accepted from the process 2. The characteristics of the transactions are shown by using a decision box D1 to determine whether to cancel or process further. And these decisions are handled by the terminal controller, and the process 4 transmits the page to the terminal, and decision 2 and decision 4 to checking decisions or the decision box to know whether the form needs more pages or not. So then D3 is the decision for the structure of the form to validate the input. If necessary, the user reviews whole system in process P9. The central computer then transmits the diagnostic code back to the terminal controller in P8. After reviewing, the transaction flow is closed and exit operation is performed. And this is the entry point and exit point after all the decisions and processes are to be performed. So next, implementation of transaction flows. So how the transaction flow is going to be implemented, in what way, in what decisions are used here, what processes, what are the steps to be taken here to implement those transaction flows. So first one is transaction flow is usually in design of system control structure and associated database. Every transaction flow has a design structure and a database to be maintained, should be maintained. So, and every transaction is represented by a token, and transactions are placed in TCB, nothing but transaction control blocks. This transaction control block consists of all the transactions which need to be executed or processed, and transactions in transaction control blocks are placed according to their flow. So transaction flow, whatever the transaction flow is placed, that transaction flow is graphical representation of a token. Whenever the token is issued, then the transaction flow defines the graphical representation, and it is processed in the form of forms, and it is placed in the transaction control block, and from the transaction control block it is going to be processed. And this transaction flow graph is not control structure of program but control structure of a system. So this is the, see here, transaction flow graph. Input A, B, C, D and E are the some of the nodes processes which is used to perform as output. The transaction goes through input processing and passes through A, and the result of A passes through to B, followed by process C. The transaction then through either D or E. In this way, the one transaction will be raised, output transaction. In this way, the another transaction will be raised. So this is the transaction flow graph, and here we are taking the control structure. System control structure is an example for this transaction flow graph. Here we are taking the example as operating system, input module, output module, and A, B, C, D. These are all nothing but operating system, process 1, process 2, process 3. Here the operating system handles the 5 processes, application processes, and these are all the process queues, dispatch queues, output queues, and disks and tapes. So executive, scheduler, and dispatcher. Executive is execution purpose. Scheduler is to schedule the processor, which one is entered into the processing state, which process is going to be entered into the processing state, and dispatcher is nothing but dispatching from ready state to the running state. All this can be handled by the operating system, and this is the system control structure which defines one of the best examples for the transaction control flow graph. So this is nothing but a implementation. Next, complications, nothing but a problems. So how the problem rises in the transaction flow? Generally, the common problem, every transaction, not only every transaction, every software application, any application has problems, has bugs will be raised, some errors will be raised, so problems will be created. So same here also in the transaction flow graphs. In the transaction flows, there is a complications. So that complication mainly is nothing but a birthing of new transaction. Nothing but new transaction, suddenly birth of new transaction will be raised. It creates a so problematic for transaction flows. So what are those birth of new transactions? Defines in 3 ways. One is decisions, biases and mitosis. There are different possible interpretations of the decision symbol or nodes with the 2 or more outlinks. It can be a decision or biases or mitosis. This leads to a problems. This leads to a complication in transaction flows. That defines a decision is main complication. Sometimes it gives a complication. In sometimes it gives a better results. So what is how it can define mean? Decision defines alternative ways. If decision yes, one alternative method will be performed. If decision is no, another alternative method will be performed. So that is one of the decision. Next, coming to the biases, one incoming transaction creates process, then suddenly it gives the birth to the new child transaction, but whatever the previous transaction is executing, it keeps its own identity. Such type of complicated method complication is known as a biases. So next, coming to the third one is mitosis. So here the parent transaction is going processing, suddenly it is destroyed and it gives two birth of new true transaction. Birth of new transaction, new transactions will be created, and this method is known as mitosis. See here, see these diagrams, you will better to understand about this. So this is the two alternative decision. Decision gives two alternative methods, either this way, either this way. And second one, biases. This parent transaction defines, suddenly this is processing and suddenly it gives the birth of new child transaction, and this keeps its own identity. That's why two transactions will going to be executed. Here this is called biases. And here, coming to the mitosis complication, parent transaction going to be executed, suddenly it destroyed and gives the two birth of new transaction, two birth of new child transaction. So this method is known as mitosis. So this is about complications. Next, applications where the transaction flows is mostly used in real-time system, and these transaction flows are essential for defining requirements of complicated systems. Mainly complicated systems, to define the complicated system, we'll go for the transaction control flow graph also, and especially used in online systems and ATM transactions, and mostly used in large systems such as airline traffic control, for air traffic controller and airline reservation system also will use the transaction flows. Next, coming to the last way, defining the structure of the transaction flow. So structure means it is not a control flow graph. Structure or designing, how the structure defines in the some of the steps, some of the reasons to be ill structured. Transaction flow is not a super structured way. It is some of the reasons which defines, which doesn't defines it is a graphical 100% graphical representation, because here some of the reasons why it is model of a process, not just a code. Only to be processing, it is a model. Humans may be involved in loops decisions, so you cannot beat human behavior to the software. Part of the flow may incorporate the behavior of the system over which we have no control. No small part of the transaction flow exists to model error conditions, jumping out of loops go to statement. So some of the loops go to statements, all can be defined in the transaction flow structure, and these are all the reasons to be not structured 100%. So another some of the reasons are the number of transaction complexity, individual transaction grow. So generally complexity, individual transactions all can be grow. Individual transaction can be grow over time as the features are added. So this can also defines the ill-structured way. And systems are built out of models and transaction flows. It results from interaction of these models. This also can be defined as the systems are built out of models. And if there is any interrupts occur, if there is any priority way, if there is multitasking, multi-computer, synchronizing, parallel processing, all these consequences affects the structure of transaction flow. So we can say these all defines the ill structure, which depends on the interruption, priorities, multitasking, multi-computers, synchronizing, parallel processing, all can be affects the results of the transaction flow structure. And this is about the transaction flow. Hope you guys understand about these transaction flows, and thank you so much.